And from here, we're going to take just a few notes over the material. And the first thing I want to talk about is observations versus inferences. What makes something an observation versus an inference? You actually see it. So observations is seeing. Is that the only observation that can be made? So what are observations?
The idea of observing.
And yes, we're going to use our observation skills. And what are those?
Methods, I don't know.
Looking is one of them. What's another one? Smelling. Tasting. Shiloh, you said feeling. Are there any others? Hearing. So what are those things? What do we call those?
The five senses.
Your five senses. So observations are when we use our five senses. So, what's on the screen?
A hurricane.
Is that an observation?
Yeah.
I disagree.
No.
What's really on the screen?
Light.
Okay, yes. What else? Probably an infrared image, okay.
There's a moving picture.
Oh, okay, so it's a moving picture. That's one observation. Give me some more observations.
It's red.
It's red, okay. Yes?
Light, it would be wet.
It's moving. How is it moving?
Spin.
Spinning. What direction?
Counterclockwise.
Counterclockwise. That's actually really important to know. It's not only just rotating, but it's rotating counterclockwise. All right, what else do we notice?
Middle. Northwest.
Okay, so we got a hole in the middle.
That's called an eye.
Coda, what'd you say?
Moving northwest.
Moving northwest. We're missing some really other key observations here.
It's in the Gulf of Mexico.
There we go. It's in the Gulf of Mexico. Guys, those are observations. You're looking for the details. And a lot of you guys immediately said, what is this? When I asked you first, what do you see? A lot of you guys said right away, what do you see?
A hurricane.
You can see a hurricane. That is your inference. Your observations is that you have a circular item rotating counterclockwise in the Gulf of Mexico. It looks large. It has a hole in the middle. Those are your observations. And then your brain very quickly takes your observations and then tries to make sense of those observations, and that's called the inference. So an inference is when we're using our past observations to then draw conclusions about what we're seeing or what we're observing. And so that's the difference between an observation and an inference. And a lot of times in earth science, most of what we do in earth science is actually done through inference. It's not always easy to replicate geologic processes in the lab. So we have to use our observations and make inferences based on what we see. So watching a sunrise, tell me, is that an inference or an observation?
Observation.
It's observation. Grass is wet, it must have rained.
Inference.
Which part's the inference?
It must have rained.
Okay, it must have rained. Which one is the observation?
The grass is wet.
Grass is wet. so someone is home because the lights are on.
Inference.
And which one's the inference, which one's the observation?
Because the lights are on.
Yeah,
The inference.
And
No.
Mike,
Someone is home is the inference,
okay?
and because the lights are on is the observation.
There we go, so observation is the lights are on. Inference is somebody must be home. Are inferences always correct? Is it correct that because the grass is wet, it must have rained? So why not?
Because the dew, or someone could have had a hose or a sprinkler.
Okay, so it could have been a sprinkler system, could have been dew, so there's lots of other ways. The grass could have been wet, you could have had a pet with an overactive bladder. So lots of ways that the grass must have been wet. Now what about the second one? How many of you guys left your house today with the lights on? Bad. Just go around, turn off your lights before you leave. How many of you guys left your bedroom light on before you left? Good job, Randy. I'm proud of you.
Those are rushed.
Ah, you guys even got to sleep in.
Cody can head for
I stayed awake.
Okay, so here, I want you guys to share with your friends here for a minute. In just a couple of seconds, I want you to share how you feel about science. Do you like it, dislike it? Take a moment and share that with your partner.
It is in the next video to you.
They won't like it. And me, see? They won't like it.
But if you do that,
I'll let him just comment because he's the one teaching. He has to like it.
Okay? So how many of you guys like science? Just the general thought of science. Wow. How many of you guys dislike science?
We just like
Oh.
you, Mr. Thomas.
There's no pressure.
It means we only take this class because you're teaching this class.
Yeah. Alright, for those of you guys who don't like science, why do you not like it? What is it about science that you don't like?
It's not that it's hard, it just gets boring.
Why?
Because there's like so many things that you have to remember to do, and like dates and times.
Sounds more like history.
But but people in like they have to mix like some of the other classes in with it because like they have to teach us the history of science with people who like who invented electricity and stuff like that. I mean that's a given.
Mm-hmm.
And it just gets old.
Okay. What do you guys want to learn out of this class?
space.
I wanna
Space?
learn
What about
stuff
space?
up with my mind.
The kind of things that
Planets?
Galaxy.
Galaxies?
Rivers.
Okay.
constellation, constellation.
Alright, what are some other things you want to learn about? You said rivers? What about rivers?
But I remember taking this class before, kind of like the bends in it and stuff, and how stuff will collect in turns. Like,
Okay.
I watched that gold rush stuff, so it's kind of cool to know that there's like background knowledge, like where
Yeah.
they're digging and stuff.
Notice where they're finding gold. It's really interesting. In fact, probably at the end of this week or at the beginning of next week, I'm going to hand out a sheet of paper I want you guys to keep a hold of all the way through the course. And it's called Central Themes of Earth Science. And one of the major themes in this class is going to be that current geology provides insight to past environments. So how can you look at the geology of a road cut in Alaska and know where to find gold?
But they dig, isn't it, like where old rivers used to be?
Mhm.
Like in the bends in it?
Yeah.
I know.
Isn't it like where there's fertile soil?
Not always.
So like where it's like really mineral.
Yeah, most of the time that you find like the gray dirt, it's usually clay. That's kind of a good sign. So that's definitely one of the things. What is something else you guys want to learn about earth science? I'll admit, we're not going to get too much into space. We will talk about space a little bit. That's mostly for astronomy. We're going to focus more on geologic processes.
When it gets forward, do we get to make bomb rockets?
No.
Why?
Storm.
That's like the perfect thing.
You want to learn about storms?
Yeah.
Yeah.
Clouds.
We'll learn about that for sure.
That is like the most like perfect thing for this class. It's leaving Earth and going into space.
Can we like judge what kind of weather we're gonna get by the clouds or something?
Yep.
Like what kind of rain?
Yeah. We're going to have you guys learn how to predict the weather better than the weatherman. Well, that's going to be kind of neat. How to predict weather without needing the weatherman. Okay. Let me skip ahead a couple slides here. Now let's get into the scientific method. And you know what? I am going to skip ahead. Let's just keep doing this here. Let's move ahead a couple slides. Boring, boring, boring. Ah, here we are. Okay. So we think about scientific method. From the website, you guys pretty much learned to identify the problem, right? What does that mean?
What was the question?
Identify the problem. What does it mean?